Welcome to the Explainer. Today, we are getting into the science behind one of the biggest consequences of a warming planet, rising seas. And we're going to be using the landmark report from the IPCC as our guide. To really understand why the seas are rising, you've got to start with one single crucial number, and that number is 89%. That's the absolutely staggering amount of extra heat from greenhouse gases that our oceans have soaked up. You know, the Copernicus Marine Service calls the ocean a critical climate regulator. And it makes sense, right? You can really think of it as the planet's giant heat sponge. It's soaking up all this energy that would otherwise make our atmosphere way, way warmer. But all that absorbed heat, well, it doesn't just disappear. And this diagram right here shows you just how connected everything is. You can see how that heat, once it gets into the ocean, kicks off this whole cascade of effects with the ice sheets, the glaciers, and the water itself. It is all one big system. Okay, so let's really dig into this first key concept, how the ocean, acting as this giant heat sponge, is really the main cause of everything that comes next. It's actually a pretty straightforward chain of events when you break it down. 1. Heat gets trapped in the system. 2. The ocean, bless its heart, soaks up almost all of it. And 3, that energy has to go somewhere, right? It sets off this two-pronged physical response that scientists can now measure with, frankly, incredible precision. So what are those two consequences? Well, they are the twin engines of sea level rise. First, the ocean water itself is literally expanding. And second, the world's ice is melting right into it. Let's take a look at each one. Okay, the first effect has a fancy name, thermosteric expansion. But honestly, it's just basic physics. When you heat water, the molecules get all excited, they move faster, they spread apart, the water gets less dense, and it takes up more space. Now imagine doing that on the scale of an entire ocean. Yeah, that expansion really starts to add up. And one look at this map tells you everything you need to know. This isn't just happening in one or two places. All those reds and oranges, they show this widespread warming of the ocean's surface all across the globe. And that is what's driving that expansion, everywhere. Now for that second effect, the Great Global Melt. What's really fascinating here is that you get a totally different story depending on which pole you're looking at. The IPCC says with high confidence that the Arctic is rapidly losing its summer sea ice. But in Antarctica, the sea ice area hasn't really changed much. And that's because for sea level rise, what really matters is what's happening on land. And this is the crucial part. The massive land-based ice sheets, that's where the real action is. Since 1992, Greenland and Antarctica have together lost over 7,500 gigatons of ice. I mean, that's trillions of tons of water that used to be locked up on land, and it has since flowed directly into the ocean. So let's put it all together. You take an expanding, warming ocean, and you add trillions of tons of new meltwater from glaciers and ice sheets. What do you get? Well, you get the consequence we can all see and measure, an accelerating rise in the global sea level. But here is the absolute kicker. It's not just rising at a steady pace, it's getting faster and faster. Just look at these numbers. The rate of rise between 2006 and 2018 was nearly 3 times faster than it was for most of the 20th century. That is a major, major acceleration. If you look back at the whole period since 1901, the picture was actually pretty balanced. The two biggest causes were almost neck and neck. You had melting glaciers and that thermal expansion we talked about, each one causing about 40% of the total rise. But, and this is a huge but, that has all changed recently. The IPCC now says, with high confidence, that since 2006, the melt from land ice, so that's both glaciers and those giant ice sheets combined, has actually taken over as the single biggest reason our seas are rising. So with all that in mind, where is this all headed? Well, the projections from the IPCC really show just how much our choices today are going to shape the world map of tomorrow. This is where it gets real. The report shows us two very different futures. In a high-emissions world, we are looking at a likely rise of about 2.5 feet by 2100. But in a low-emissions world, we could cut that rise by more than half. The path we take, well, it determines the outcome. And it's not just about how high the water gets. All this heat energy is also driving extremes. This map shows what we can expect for marine heat waves, these really damaging periods of extreme ocean temperature in that low emissions world. You can see
they still become more common.
But now, look what happens in the high emissions world. The difference is just staggering. I mean, the dark red covers huge parts of the planet. Those are places where these devastating heat waves could become basically permanent by the end of the century. And, maybe the most sobering point in the entire IPCC report is this one. These changes are essentially locked in for a very, very long time. Because the deep ocean moves so slowly, the heat it's already absorbed will keep driving sea level rise for centuries, maybe even millennia. The decisions we're making right now have consequences that will far, far outlive any of us. So what this all boils down to is that the physics are undeniable. The ocean has taken on a tremendous amount of heat. As a result, it's expanding and it's melting the world's ice. The science is clear. Our future coastlines are literally being drawn today. The only real question left is, who's holding the pen?